Number 8, graph the piecewise function f of x, then describe the continuity of f of x. So once the graph, then describe the continuity. I'm going to go ahead and describe the continuity first. If we look at the top of this piecewise, everything should be continuous because there's no division, nor any square root. Down here, this equation, the x is in the numerator, so the denominator can never equal 0. Remember, that's how you get a break, so the denominator equals 0. Well, 3 can never do that, so we have no problems here either. So the only break we might possibly have is at 3. And the way you would determine is you just plug in 3. If I plugged in 3 here, that would be 3 over 3. Those would cancel, and so I'd have negative 4. And up in the numerator, if I plug in 3, 3 cubed is 3 times 3 times 3, which is negative, this will be negative 27, plus this would be 21, so I'm now at negative 6, plus 2 gives me negative 4. This graph should be continuous the whole way. I'm going to go ahead and plot this point at 3, x equals 3, should have the y value of 4, right there. This would be an open circle, this would be a closed circle, so either way they would combine to be right there. So this is continuous. I'm going to go ahead and put that here. This graph will be continuous. There will be no breaks. This would be a graph going down 4 units. Down 4 units over 3. I'm going to put a color to this here. Down 4, 1, 2, 3, 4 over 3 units. And it would continue on this path like that. So if I wanted to shrink it to over here, I could. But yeah, that would be kind of the general idea of the graph. So it'd be like that, kind of going off the screen that way. So I'll go ahead and shrink it now that I got the mark on there. Okay, so we have that graph, and then this one would be an S-curve, and it should be a negative S-curve, so it'll be coming from up here through that point. The y-intercept, it says, is at positive 2, so it's actually going to hit here and somehow curve back up. Let's see how it works. You could plug in numbers if you want to do it exactly, but I'll just come over here and look at it in the calculator. So to graph piecewise, you go to this button next to 9. That if you can't, it's hard to see, but that's an absolute symbol, and then next to it's the piecewise symbol. I have 2 equations, so I'll choose this one. My first equation was negative x cubed, and then I added 7x, and then I added 2, like that, and this is when x is less than 3. And over here I had negative 4x divided by 3, and this is when x was greater than, so you do control equals, greater than or equal to 3. I graph it, and I see something I messed up big time, is that 4 value we had was negative 4, so my graph should have been not up 4 units, down 4 units. That's why we always check with a calculator there, isn't it? Just dumb mistakes that even teachers are prone to make. So there's that. Graph needs to be shifted down here. And so the S-curve comes out, and I'll get some points from it. So let me take a picture of this and drag it over here. And so if we wanted to plot some exact points, you could look at it and see where it looks like it's down about 5 units when it's left 1.5. So it would be somewhere in here like that. And cross the x-axis between negative 2 and 3. So somewhere in here. And we'll continue on. So this would go up this way. And then this would come back up. And at 1, it looks like it'll cross in here somewhere at that. This will be like this. And then this point goes way up off the graph. So by the time we're over here, we're off the graph again. And then come back down and hit between 2 and 3 over here. So it'll be like this. That's obviously really, really ugly. That's your general idea of how your graph would look. And you can see, though, it is continuous.